Thank you. So everyone, as James mentioned, my name is Carlo. I am the media officer for the Game Development Club at San Jose State University. If you're at the meeting, I'm not sure anyone here was. This is going to be the same presentation, so hopefully I don't bore you too much. So as James said, this is an introduction to game programming. Obviously, a lot of you just wrapped up work on your board game. You should have 2 games under your belt, the Race to the Finish, and then of course the more traditional board game that you've just created. And now after that, you'll be moving on to Unity to work on your digital game and hopefully finish one for your final project or do a presentation or interpretive dance. We're still looking for an interpretive dance presentation, people. Anyway, this presentation is going to be, here's the outline by the way, it's going to be a basic coding overview and introduction. I'm not going to go into actual code. I'm going to keep it sentences. It's going to be pseudocode. Everyone can understand English, hopefully, and that's what this is going to be in. It is not going to be in some language that uses symbols and stuff. Don't worry about that. I'm going to talk about the differences between regular coding and game coding for the programmers in the room because there is a slight difference. It's not huge, but it is something to keep in mind. A couple of best practices for the artists who want to try programming, some tips that I can give you that will help ease the process and transition, as well as some basic game design principles, which you should have learned an hour ago. Also, please forgive these slides. I'm not very good at PowerPoint or anything. So the first thing on probably everyone's mind is what is programming? And the best way that I like to describe it, and I have a couple ways I'm going to describe it in this presentation, is it's kind of like instructions. Essentially, a computer is pretty stupid, all things considered. And the only way that we can tell it to do something we want is to be very specific and to speak its language. It's not the language of love. It's not French, Italian. No, it's C# and Java. For your case, you're using Unity in this class. All of you have to use Unity for your first project. If you're familiar with another game engine, you may use it after the Unity project. We're all using Unity because we're all going to learn together, and it's going to be great. If you're using Unreal, you need C++. There's also blueprints for that one. Godot uses GDScript. It's similar to Python, if that's more your thing if you're a Python programmer. And GameMaker uses GML, which is Java-ish. You can ignore this bottom part. I'm not going to be looking at the actual code of anything. So how to program. Now, I use this analogy as well. A game engine is kind of a language teacher, and for those of you who have obviously taken an English class anywhere, even at this school, they can be really picky. Usually I'll get an essay back and the entire thing just has red marks on it, and I'm like, what did I do? And I didn't put a comma in like half the places I should have. And essentially, a compiler, or what you're writing your program in, is going to do the exact same thing, except instead of put red marks all over your screen, well, it is going to do that. It's also going to say, hey, you did this wrong, and your game doesn't work, and your computer's overheating now because you did it wrong. And for instance, this simple line of what essentially I'm doing here is I'm making a variable like x or y in like calculus or algebra. If I don't have this, it doesn't work. If I don't have this, it doesn't work. If I'm missing a parenthesis, or I guess an apostrophe in that case, it doesn't work. You need to be very specific about how you say things to a computer because it's very specific in itself. If you don't do it right, it won't like it. And for a lot of people, that can be very frustrating because your intention doesn't always actually translate to what a computer will actually read off of it. So the long story short here is you have to think like a computer. A computer is very meticulous. It really stresses those details. So obviously a computer will do your instructions, and as I was kind of saying, actually bled into this slide, my bad. But yes, it will read it exactly as you have them, so you have to be very specific. In a lot of cases, in almost every engine, including Unity, what you're essentially doing by giving a program to a game object, when you create your game object, you can think of them as kind of the player here, you're giving them a special list of instructions. Now, some of these instructions can be as simple as shooting or whatever. Some of them could be moving, left, right, up, down, something like that. Now, as I'm sure you're noticing, something on the screen is moving. And as I said, I'm really bad at PowerPoint. So instead of making a PowerPoint, I made a game and made it look like a PowerPoint. And since I made a game, let's take a look at some of the code, and I can kind of explain to you how the reasoning and thought process of how I made it works. Okay, that's a little much. Let's reel it back. Let's roll it back here a little bit. So programming for games. Let's start with another analogy. I like analogies because they're a good way of relating something you don't know with something that you do know. So let's say you just got hired by, I don't know, 21st Century Fox or 20th Century Fox. I'm thinking of like Futurama or something. And you are now a director. Your game objects are the actors clamoring for the script, which is the code that you're going to give them. Like all good actors who want to memorize the script, their lines. They're going to read the script over and over and over again like an obsessive child. Game objects and your program will do the exact same thing. If you give them a line of code, they will execute it over and over and over again. They will do it in steps. In fact, that's what we usually call it. Steps and frames sometimes get confused. So most of you are probably who play games are probably familiar with the frames. They're technically different, but it depends on what engine you're using. So we can say in this case, in 1 second, a program will execute, or the game will execute your code 30 times a second in 30 steps. That's the kind of language I'll be using here. So for the simple move left, move right, the logic can be broken down like this. If the player presses the A button, we want them to move to the left. And yeah, you can't really see this keyboard, but if the player moves to the right, or sorry, if the player presses the D button, we want them to move to the right. I think that's pretty simple logic, but you can see I've laid it out in a very specific way, and this is more or less the same way that you're going to be doing it if you're programming in Unity. An if statement followed by a then, a cause and then an effect, the consequence. You press the A button, therefore this thing moves to the left. I'll give James a link to post to the canvas so you can download these slides and look over this code in case you're interested, but I'm not going to go over it. Obviously, this is more of a general tutorial. So programming for games specifically, as I mentioned, there are some differences. Game objects have coordinates, as you might have guessed. In the case of moving an object, if let's say this is the origin, 0, 0, if I want it to move to the right, I add to its x value. That should relatively be simple to understand. If I add 8, it is now at 8. Specifically, in a program, these variables are constant. In the way that's laid out in a program, it's kind of like an equation. It's like x plus 8 is 8, right? And you set 8 to x. So now the object is at 8. But because I keep holding down the D button and that game object keeps reading this script over and over again, as long as I'm holding down D, it will keep adding 8 before. So now it's at 16, now 24, now 30, now I stop, and that's like 32. I can't math. So it's important to understand that these variables are permanent. They aren't like math variables that just disappear at the end of an equation. They persist. In many 2D engines as well, the y-axis is actually flipped. I think it's the case in Unity 2D. It might not be. But what this means is that to go up, you subtract from the y, and to go down, you add. Why is that? Well, if you're familiar with CRTs, and by that I mean those like nanotube thingy, whatever, something, whatever. They actually started scanning from the top left corner and produced light left to right, down one line, left to right. And that's why the origin for even your cell phones is in the top left of the screen, not the bottom left. So the y-axis is flipped when you're doing coordinates. As I mentioned, this is all in a loop. And by that I mean the variables stay the same. And of course, again, your game objects will read your script over and over again. I'm repeating that because it is important. There are also many solutions to the same problem. If you look up an answer or ask for an answer on the Piazza when you're doing your Unity games, a lot of the times you might see different answers, and sometimes all of them might work. All 4 of these methods do the exact same thing, just in a different, oh, that's blocking it, just in a different direction. They all do the same thing with varying degrees of efficiency. Some of them are terrible, don't do them. But they all accomplish the exact same goal. It's important for you to make variables as well. I'm not going to stress about, again, this too much just because it's kind of like a programming niche. But the other one thing here that's important is to comment, though. Is to comment things. If you don't comment things and you like take a break, maybe you start on your Unity project really early and then you get flooded by like an art project or a CS project you have to do. You're like, I have to wait like 2 weeks to start working on this game again. And you come back to it, odds are you're probably going to forget what you even did in your code. If you comment them, you put like a little note to yourself that, hey, this code is supposed to do this. It'll help you get acclimated. And trust me, having worked on several game projects that spanned months and actually one time a year, this is really important when you want to get back to what was I doing? So designing the game, and this is where we get into the fun part for most people, the Mario Maker part. Because the reason why I like Mario Maker is because you don't really have to stress about the programming. You just get to place blocks everywhere and then jump around in your environment. But once you have kind of the shell, once you have movement, once you have your core mechanics down, you can get into creating goals and getting to those aesthetics that we were talking about, how those mechanics create those dynamics which lead to aesthetic. The first one, of course, is we want to add a goal, or at least I like to. I like to think of the goal for the game, and the first one here is let's say we want to go ahead and add the score to it. Boom. Okay, it's in the top left. Perfect. And then obviously, if we're just adding score, I mean, this is a pretty easy game. I can just stand here and like be winning. I mean, I'm at like what, like 30 points or something. I'm not even doing anything. I mean, I like this game already, but some people aren't gonna like this. Some people aren't gonna like doing nothing. So let's add a little bit of challenge. So let's add like a ghost like thing. I don't know. Maybe like something that's not round. Like sure those things. Those like trapezoids that aren't really round. Anyway, designing the game, and again, you had this lecture, so I'm kind of going to give a summary on this, is important because you need to start from the designer's perspective of your mechanics. There are the things that you created first in your board game, because obviously to make the board game, it had to have rules that your players then had to follow. In the program, you can't really do that outside of board game simulator, okay, or tabletop simulator, okay, because that's kind of different. But the point is, there have to be rules, and your program has to enforce those rules, which is why bugs tend to happen, because in all of code, there's always some fringe case that someone always forgets, and then you get a game like Anthem or No Man's Sky. So the mechanics of what we have going for right now are essentially, we have movement, right? We can move in 4 directions. We have dodging. There's no collision on them. We'll get to that in a second. We have, and score attack. We've tried to get the highest score, and that's one of the core mechanics of the game. Some dynamics of gameplay, some things that kind of evolve. I can kind of move in a circle and avoid these guys, right? Like that's not too bad. I can like maybe hide in the corner. Maybe they'll never see me if I just kind of go over here, right? And of course, the aesthetics, the things that come from the dynamics, why you would even play this game, even though it's pretty relatively plain so far. But part of the challenge, there's a bit of challenge here, right? Overcoming unnecessary obstacles. That's kind of part of this. Like, why would I do this? Because you want to get points by staying alive as long as possible. Conveniently, the score is also like it goes up 1 every second, so it's very convenient for me to just use that as a timer. The other thing, though, is I will go over a bit of game logic. This is going to be a lot harder to follow if you've never done this before, but I'm going to try my best. So the first thing to note is this is the logic of those ghosts that were following me. This is relatively simple. I know there was a better way to do this that involves vectors, but that's way too complicated for this. So if there is a player, get his address. And what that means in layman's terms, I'm going to use the same word actually, is when you're sending your script to your actor, you need to know where they live. So you get their address and you send them the script and say, hey, follow this script, learn it, live it, love it, you know, like Heath Ledger. So in the context of the game, you're getting his address in the computer, the memory address. Once you have him, I want the ghost to look at the character. I want you to observe him. And while you're looking at him, you can see at the top there, the ghost is always moving 6 spaces wherever it's facing. So as long as it's facing the player, it will move 6 pixels toward him. I add some random variants because I say you can kind of look to the left, maybe a little look to the right, you know, just to kind of throw things a little bit, throw a wrench in the mix, and then some flanking stuff. And then the flanking stuff is essentially I ask it to roll a dice. If it rolls a 1, then I want you to try and go around him for 3 seconds. And you can either choose to flank left or right, and that's basically the thinking there. And again, you can see I've structured it in a very specific way where I get to use this as a highlighter. If this happens, then this is a consequence of that happening. And that's essentially mostly how a computer works. And on the base level, most of your games will start like this. And in fact, most of your games will probably end up looking like this after the first prototype. You have, you know, a score counter, your basic goals, some enemies that may or may not work. And that's pretty much it. And honestly, this is fine for a first game, especially a digital game. A lot of game designers that I know, Tyler Gillale, Edmund McMillan, if those you don't know those, they made Super Meat Boy and The Binding of Isaac. A lot of them recommend that you just make a game in a week and whatever you have, publish it, because you have to get your first game out there. And for all of you, that's not a worry because you've done that. But making a digital game, especially if you don't have experience programming, can be very difficult. And obviously right here, you can already see I've made a couple of changes that kind of make this game a little bit more engaging. Obviously, I've significantly reduced or increased the amount of time it takes to get points passively. I have added hitboxes so I can actually die here. I'm trying to avoid this. This is really hard on this keyboard, by the way. This is not how you should be playing video games. Oh no. Okay, well, I might have made this a little bit too difficult, apparently. But essentially, I've added coins now, so that instead of just hiding in the corner, you kind of have to be more active. It creates more dynamics. Now, you can just wait. You can play for a ridiculously long time and probably get the same score, or you get 10 points for getting those coins. And you can see just how adding that one extra mechanic of there are coins that give you more points kind of changes play. So now instead of having to aimlessly go in circles and just avoid them because they're flanking me for all of eternity, I've now made it so that there's an incentive to kind of be risky, right? I've added more options for the player. And that's really all you need to do to kind of make a game that's relatively simple, more and more engaging. But obviously, you don't want to flood the game with too many mechanics and get out of scope. But that's a different story for a different time. So in conclusion, the code is in GML. Don't worry about that part. Try not to get frustrated. Obviously, for a lot of people that start programming, it's hard. I remember when I first did it, I was learning Java in parallel with trying to learn GameMaker. It wasn't the best idea because now that I look at that code, it was very clear that I was learning how to program while I was making it. We all look back on like our first programming projects like, wow, we had no idea what I was doing. But trust me, you gotta get through the frustration, gotta get through all those errors that pop up because the payoff is huge. Unlike a CS class, a game making class or a game engine gives you immediate and visual feedback instead of just, oh, here's text in a console. It's, oh, this thing's moving on the screen. I've done something. It feels, at least for me, it feels a lot more rewarding when I doing this kind of stuff. And always remember your goal. And in most cases, it's to pass this class, but sometimes a lot of people have made genuinely fun games. And I'm not saying all games have to be fun, but if that's your goal, go for it. You guys can do it. You guys did it for the board game project. I'm going to be reading the rulebooks on those. Please tell me you formatted them because that makes grading a lot easier. And that's basically it. Yeah.